Many process systems have to be supplied with a variety of fluids in order to operate properly. These fluids, which include liquids and gases, are carried throughout the plant by a maze of piping systems. The flow of the fluids through the piping systems is controlled by valves. Maintenance personnel are responsible for servicing and repairing different types of valves to keep plant systems operating smoothly. Valves are used to control the flow of fluids in piping systems. When a valve is opened, fluid flow begins. When a valve is closed, the flow is stopped. Many valves are designed to operate in either the fully open or the fully closed position, but not in between. In this unit, we'll call these valves on-off valves. In addition to starting or stopping the flow of a fluid, some valves are designed to regulate flow as well. This can be done by partially opening or closing a valve. Valves that operate in this manner are sometimes called either control valves or throttling valves, since they regulate or throttle flow. The largest component of a valve is the valve body. It provides a path for fluid flow through the valve. The valve body can be made of different materials, such as bronze, cast iron, and stainless steel. The material that's used depends on the valve's application. The valve body provides the means to connect the valve within a piping system, and it houses many of the valve's components. One of the internal components is the valve seat. The seat is a stationary component of the valve, and it can be threaded, press fit, or welded into the body of the valve. In some cases, the seat is cast as a component of the valve body. In high-pressure, high-temperature situations, the seat may be both threaded and welded to prevent leaks. The seat is used together with a movable component called a disc to control flow through the valve. The disc is attached to the stem, and the stem connects to the hand wheel. The hand wheel is used to screw the stem in and out, which in turn lowers or raises the disc. If the hand wheel is turned in the open direction, the stem moves up and the disc moves away from the seat. As a result, flow through the valve is increased. When the disc reaches its limit of travel, the valve is fully opened and maximum flow can pass through the valve. If the hand wheel is turned in the closed direction, the disc moves down toward the seat and fluid flow is reduced. When the disc presses tightly against the seat, the valve is fully closed and flow through the valve is stopped. In order to maintain a leak-proof seal, the faces of the disc and the seat must be smooth and fit together perfectly. The removable bonnet is designed to allow access to the interior of the valve and to provide a leak-proof seal. It also supports the other valve components. The bonnet can be bolted, threaded, or welded to the valve body. At the point where the stem goes through the bonnet, there's a recessed area called the stuffing box. The stuffing box holds the packing. The purpose of the packing is to prevent fluid leaks from the interior of the valve, while allowing the stem to move freely through the bonnet. The packing is made of a material that can be compressed to form a tight seal around the stem. To compress the packing, a component called the gland follower is attached to the valve. The gland follower can be bolted or threaded onto the valve bonnet. When the gland follower bolts are tightened, the packing is compressed to prevent leaks. Valves come in many shapes and sizes, and they can be used in many different applications. The way a particular valve is identified can depend on factors such as its physical characteristics or how it's being used. Among the common ways to classify a valve are by the shape of its disc, by the shape of its body, by its function, by the conditions under which the valve operates, and by the method used to connect the valve within the piping system. Keep in mind, though, that valves are often identified using more than one of these classifications.